So this course is regarding AIOps. Probably let's start with the icebreaker. You must be hearing AI everywhere. And this IT operations is also not like something that is not affected by AI. You must have realized like if you are working on any field, I would say be creative. First, we thought it won't be creative in IT, wherever you are, like in web development, even SRE support, anything like everywhere you will see either AI supporting it or completely changing the paradigm how it works. Yeah. So let's start with like what this course is all about, what you expect like to get from this course and what actually the AI ops is, right? So there are two parts, AI and ops here is like IT operation. So it's just you can think of it as like one niche application of AI in IT operation in one of the field, and we will also discuss why we even need AI in like this field as well, and how it helps to get more out of it, right? And like should be benefited from this course and what we are going to learn. So in nutshell, when you use like LLM or any machine learning, classical machine learning or anything in your IT operations, that's called AI ops. And let's start with little bit intro. So I am working around like total work ex of 8 years. I started with like C, Java, and then like for last I would say 6 8 years it's just Python. I used to work in TCS, and right now I'm living in Pune, based out in Pune, working in UPS as an AIOps engineer. So let's first start with like what was there till now. I would say it's like your traditional IT operation thing. So in traditional IT operation, what you mean is like whenever and this applies to all the support person, SRE persons, and even the monitoring thing. So in traditional IT operations, you had tools like Grafana, you had Netcool, that is like from IBM, and there was a simple workflow. Even if you take the cloud in traditional IT operation, how it used to do was like you just put a threshold. If my CPU goes above 80, I need to get an alert. If my website loading time or the latency is going above this threshold, let's say 2 seconds, 3 seconds, whatever it is there, I need to get an alert. So and also like whenever you see any entry, malicious entry in the log file that okay, some Java error happened or something was reported in log which doesn't look right, so it will also generate an alert. And what you mean by alert is like it will probably create an ITSM ticket for you that okay, boss, on this machine this is what we see in the log file, can you please check? So this is good because you're tracking it like of the log to ITSM ticket and one person working on it. But the problem here was like you will get so many spam, like out of 10 tickets probably 9 of them are not actionable. So the main word is actionable, like do I need to worry about that? And by just looking at it you will know okay, this is not important, but you cannot even turn it off because sometimes it's important. So this kind of understanding, or you will say the intelligence, is missing in your traditional IT operations, and that leads to multiple problem, like you get so many false alerts, false alarms, and this leads to the problem of like whenever there is a true alarm, you will think it's a false and you will ignore it. So this happens due to alert fatigue. So alert fatigue is like when you get so many things, you cannot focus on what matters the most. And also the thing is like it cannot predict anything. So something goes bad, your website doesn't load in like 10 seconds or 1 minute, and you have tools like let's say you're using site 24/7 or something like that, and it says okay, this is not reachable, and then you go into firefighting mode and fix it. And then you realize okay, it was Monday morning and everyone logs in and the system was not warm up, or it was holiday and there was so much traffic. So then you realize okay, I could have like throw up more power or started more container out of it and scale up basically and make it better. So this kind of intelligence come from the AI ops. So AI ops is nothing but like adding intelligence with use of AI tool sets. Like it can be as simple as using statistical models to your classical machine learning models to the holy grail of AI that is nothing but your LLM, like you use Gemini models, HCPT, or whatever like LLM model you use. So what AI solves here, right? So the first is like the problem here was alert fatigue, but AI solves it by reducing the noise. So let's take one scenario where your application went down. Okay, or something, let's say, happened on the server related to network or something, and it leads to multiple failure, like one alert related to network not able to, let's say, connect to that network switch, or latency is too high, or something happened with proxy settings or certificate expired, whatever, like related to that, and it leads to a application shutdown, a downtime. And you will see multiple things that, okay, due to this network issue, database also went down, you're not able to, let's say, access it into the system. So these all things are related to one common application. So what AIOps does is, using the correlation, it understands, okay, these five different problems related to DB, related to network application down, or the latency is too high, so website is down. All these things are related to one application. So it will consolidate everything, so you have the better picture and holistic view, like what happened, and then you can work on the root cause. And also AI can help you to find the root cause as well by looking at the timeline. Okay, which what happened first and what leads to next failure. So you know, okay, I don't need to look at the DB because it is just failed because of network. So this kind of intelligence that you get out of AI in your IT operations, it's the whole thing is called AI ops. Also, proactive insights is nothing but like doing predictive thing, like doing things proactively rather than like waiting for it to break. So using the time series analysis model, the best one I could think of is from, so you can use models like Prophet to look at the seasonality and stuff that okay, during the holidays I might expect more traffic, or every Monday I am having a spike and it's not able to handle. So this kind of analysis or insights that you get is using AI only. On IT operations, it would be cumbersome task because you need to look at the charts for yourself for last 7 days, 7 months, or 1 year, something like that, quarterly and yearly chart, and then you realize the pattern. But with using AI, this can be done automatically. So that's what another aspect of AI is. AI ops in IT operation is automate response, and these two, I would say this is not AI automate response, but this is something, that's why I say it like AI ops is like the whole field. So this automate response you will see in traditional IT operations as well. But this is like, if you are saying that I am building a tool for AI ops, so I'm using AI ops for this and this, then this is something you definitely or you must have. Like I would give you an example from many organization I've seen. So there are a few common tasks, let's say common problems for your VM memory going up or going like due to Java heap memory or logs or for whatever reason, right? Or for cache, your memory is going, let's say, above certain threshold, 90%, 95%. And then how do you resolve it? Very simple. You logged into VM and then do the cleanup, right? By identifying the big files and stuff. So now in AIOP, you must, or I would say it is expected that this kind of run books, I would call it run books because it's the certain step that you need to perform to resolve that issue. So that should be automated or must be automated in AIOP. In traditional IT operations, I agree, it was there. You can use tools like IPsoft, Amelia. You can use simple Ansible run books or Puppet or whatever to just run something on your server to solve that problem. So this gives you the whole cycle that, okay, first step, problem happened, that alert generated from your agent, and it says like memory is in critical range above 90%. It came to your AIOps tool where you do the monitoring. It can be as simple as just visualization dashboard on Grafana, and then it generated alert. It can be REST, Kafka, whatever you want, and you get an email or you get an ITSM ticket on it, and then the virtual worker will work on it and resolve that problem by running that runbook. So here, you don't even need a human intervention. So this kind of fixed problem should be automated. So this is kind of a pillar of AI ops, okay? And last but not least is fast root cause analysis. So there is a limitation of human looking at so many alerts at a time. It takes time. Let's say if I give you 10 alerts and I ask you to find the root cause analysis, and also along with 10 alerts, I give you 5 log files. So by reading those log files, searching for keywords, and then matching thing with the alerts, and then finding the root cause may take a little bit of time. I'm not saying it's not possible without AI, but it will take time. But if you give all this data, dump all this data into LLM, then they can do the job, I would say, faster. Yeah, because they enter now with the new LLM models with reasoning and all, they are able to give you like answers, I would say, even better than human because they have more knowledge. I would say, for example, if you see a particular error, Java related error in the log file and you don't understand, then you need to go to Stack Overflow or documentation to find and understand what is that. But for LLM, they are trained on internet data, so they know what does this error mean and what it can create the problem. So that's what the last thing like this AIOps comes into the picture. Now I would like to show you like what this 40-hour curriculum is going to look like, and along with that I would also explain that how AIOps basically works and the whole architecture look like. So the first 2 weeks we would be focusing on foundation stuff and also a small introduction to Python. Python is, I would say, good to know for this course because we are going to use Python for all our coding and thing projects and stuff. It's not limited to Python. You can use any coding language you like, but I am a Python guy, so if you know Python it would be a big plus. So the goal in our course would be like using the tools you can do AIOps. I would say not an issue, but if you understand how all the pillars and stuff from the life cycle when one agent in your system finds out a problem, and then it sends to your data ingestion pipeline. And in data ingestion pipeline, when you process that alert, enrich it with the data and stuff, and then it goes into your machine learning pipeline, and you found out, okay, this can be resolved using this run book, and then you run the run book and the problem is solved. And if it is not solved, then the ITSM ticket is raised. So this kind of whole pipeline, if you understand, then it is also easy to do it with the tools. So in market right now, you have few tools like Big Panda. There is an from IBM. This Netcool one is also getting AI from IBM Watson. It's not popular, I would say, right now. The another tool that is very popular is called Mooksoft. So this kind of tools are mostly SaaS or license based. It costs you as a fortune. And by looking at the growth of this company, you also realize how AIOps is also not a buzzword anymore, but actually used in like very big corporations, organizations. I mean, so fun fact that Big Panda started almost like 2012 or 2010, something like that, and in less than 10 years, it was unicorn company. Like just a startup to unicorn in around 10 years is like really good. So and they provide this whole solution of AIOps as a SaaS. So first 2 week we would be doing all this stuff like creating a simple code in Python, like how do you pass the logs, metrics. But also we'll discuss the tooling because I don't want to give you like bunch of a Python code that you can't even use in your company or in your current work. I expect like mostly you are either working professionals or going into the job right very soon from college. So I would also show you like how you can do it with Python, and also we'll discuss the tools which are available in market and mostly used in company. For example, to get the metric data, you can simply write psutil Python code, get the job done, or you can use metric exporters like Node Exporter, or you can use Prometheus, which are standard, I would say. Or you can use tools like from ELK stack, like Firebase, MetricBit, AuditBit to get like logs and metrics and stuff. So we discuss both things, when this can be beneficial if you want to use Python, when you want like something lightweight or something custom. So we will explore both, and once you do it yourself, then you understand the tools better. Like once you know how it works, like backend using Python is implemented, then like when you use tool, it's like a cakewalk. You have basics, then all these IT data, logs and metrics and stuff. How do you handle that with Python, and what are the tools available? And this is something which we are going to learn, which can apply to AI ops or anything else that you are working. Okay, so here we are going to cover machine learning concepts, and this is generic. Okay, you would be just algorithm would be specific to AI ops, but once you understand the machine learning stuff, for example, here we would see like how does the classification work, how does the regression work, what are the machine learning pipeline. We would also see a little bit of neural network as well, like one or two program here and there, and see like how can you also use the old or classical neural network models to solve this problem. And you'll also compare everything to see like which model is working really good. And this concept that you are going to learn under machine learning, you can apply to anything. For example, let's say you have a project in your current job role to predict something. Yeah. And you think it's a regression problem that based on this data, I need to predict this. Let's assume house price or something. So you can apply this concept there as well. So this is like completely transferable concept of the learning. Then we will see like specifically for AI ops, like what methods are used. So it can be a simple statistical method like G-score, or you can use like machine learning concepts like isolation forest algorithm to quickly get the anomaly out of the data. Also, in later weeks, we would be looking at the LLM. So this was not very much planned, but looking at all these applications and this new model, which are able to do with like this agentic AI with all the tools and stuff. It is like very, I would say, crucial to learn like how to create LLM apps. So this is something also I would say you can use it in not just in IT operations, but everywhere. So we'll see simple how to build a RAG application. It would not be in depth, I would say, because it would be another 40-hour curriculum. But at least you will get a framework or an overall idea how this LLM apps works. And using libraries like CrewAI and LangGraph and LangChain. So we'll start with LangChain, then slowly going to LangGraph and then the CrewAI. CrewAI is my favorite, so you'd be spending more time there. How can you build an application where you can give the whole log file and based on that you can ask all the questions? So this is a very simple one where we would take the tools like Prometheus, Grafana, and LLM and put all of them together and you can ask literally the question on your Prometheus data. Okay, what happened to my CPU in last Sunday? And it should go and get the data and analyze the data and then give you the bullet points. So this kind of projects you would be building. So this is like very crucial. I would say this week 3, 4, and 5. Here I would add one more week to get your machine learning concepts and LLM concepts. I would say get it like very concrete. So later when we do the project, it is easy. Then week 5 and 6 here, I would say it would take only 1 week because practically we can do all of this in theoretically, but in practice, no one does this. Okay, let's be clear. Like for automating one or two tasks, it's fine to use Python, but mostly people use automation tools, as I mentioned, Ansible, Puppet, Amelia, IPsoft, can be anything. But this is possible, so we'll see like how you can do it in Scratch. So for simple projects, you can also use Python. And you also understand like what is the backend machinery of all these tools. So Streamlit, we will see like to create dashboards. And this is also something that I have seen. Once you learn it, you should be able to create a very simple UI for your day-to-day work, learning dashboarding, automation stuff. Like that is also one of the pillar of AIOps. And last, for information, all these projects and everything would be like completely practical. So even in week 3 and 4, it would be just writing the Python code live and running all the machine learning pipeline and stuff. LLM app, I would show the code and run it. It's not going to be theoretical. It's all going to be practical. But week 7 and 8 is like where you create the major projects, which can be like transferable to your current job situation. So you would be doing project in class, and also you need to take the project. It can be like group project or individual project based on your current job profile. And this way you would be able to like consolidate what we learn in week 1 to 6, starting from simple scrapper like getting the metrics and logs, to how do you analyze, how do you visualize, how do you automate, and how do you apply LLM on it. Okay, so that's what's going to be in last 2 weeks. So it's going to be like we would be I would be doing project based on your suggestion. We will be That's what we cover in class, and in parallel you also need to do a project and submit it. So that's going to be your last 2 weeks. We will see in demo how simple statistical model can completely change it. So let's go through the simple demos. Very simple one, Discord app. This is all dummy data, so don't worry about it. And definitely we are going to put real data as well, but yeah, just for demo purpose. So for example, let's assume this is your CPU usage and you want to find out whenever the problem happen, like anomaly happen. So sometimes let's say you are on a stable system and it generally goes like 30 to 50%. But when it jumped into like 70 or 80, let's say it is not calculated as anomaly because you put your heart threshold as 90. But if this is something happening, like if it is going like from your normal range 2 times or 3 times, it's worth to look at it, right? Maybe something is going in back and not right now a problem, but it can result into the problem if you're seeing this kind of spike. So with a simple monitoring, even on Azure, if you go to Azure Alerts and set something on your metrics, you can only put the threshold, like hard threshold, which generally doesn't work like very well because this kind of accumulate over time. So let's say there is a lateral shift from 30 to 50, you go into like 50 to 70. And you should definitely look at like what happened suddenly that my average CPU went 20% up. So this kind of thing you cannot capture with traditional monitoring system because you put your threshold, let's say 80, so only these 2 points will be calculated. Let's generate a new data and let's see. Also, yeah, downward spike is also important, that something was in proper range and suddenly there was a drop. So maybe something went down, which was using CPU, and that is not running anymore. And also, let's say it went from 60 70 to 30 50, something like that. So probably out of your 4 services, microservices, one of went down. That's why the usage went in a lateral shift. So this kind of stuff you cannot capture using normal, you can say, monitoring tool set. So here you can use a statistical model. So this is a very simple Z-score one. So Z-score is nothing but how far your point or the observation is from your mean. Okay, so from average in terms of standard deviation. So is it 2 standard deviation away, 1.4 standard deviation away, or 3 standard deviation away, something like that. So generally, whatever it deviates, if it is more than like 2.7 times, then it says, okay, this is anomaly. Probably you need to look at that. Why this is not anomaly? Because average here it was something like this, so it went only like 2 times or something. So if I reduce this, then it is identified. Okay, it's 2.5 times. So this kind of simple, if you just put this kind of simple calculation, this score calculation is not even, will not cost you any resources. It's simple formula, x minus whatever the mu by is deviation, and in most of your time series db, this must be like this is generally a function, inbuilt function, which you can calculate very fast. So this kind of a simple thing can also solve a very big problem. Yeah, and also it can reduce you wrong tickets. For example, let's take this example only. Like I'm using 60% like conservative threshold. So you would get 1, 2, 3, 4, 5, I would say alerts, yeah, or the events that CPU went 60, more than 60%. It will get resolved, I would say, because it went below 60 in next 1 minute. But at least you will see 5 events, right? Compared to, and this is not a problem because earlier it was around 50 and then it went 60 and go down. So in average, it went only 1 or 2 standard deviation away. But if you use this kind of a Z score, you will get only two. So here it's also like a win-win situation. and this works well, and this is like a stateless. So here you don't care like if your CPU is going from 40 to 80 or 5 to 20. So 5 to 20 is a bigger problem because it went 4 times. So how do you get that? So using this kind of a statistical model. Yeah, this is like hardcore, I would say like a dummy data. That's why it starts at 40 or something. That's why you will see not in 5 and 10 range. But you get the idea, like this kind of a model, you don't need to put a threshold in. It works for all the ranges. So in your company, generally we have like thousands of servers. So you and let even if in your project, if it is let's say deployed on VM, or let's say you have like, all these resources. Generally, like a really good application would have so many services from DB to UI to front end, back end, everything. So you cannot go and set a threshold, and it can also change over time with season. So this kind of approach really solves really solves work of like finding the perfect threshold. And this works for every range, be it like your CPU is very low, around 0 to 10, or very high, 60, 80. So this is based on standard deviation and mean. So I just wanted to show you like if statistical model can do this, then how what ML can do it. Okay, so this is like another demo of the same thing, the score one, but here you have more control on like how you want to generate the data and stuff. So again the same thing, and here you can also say like where this should happen and how the anomaly strength should be. So this is more like showing you like this is all built in Streamlit, which is a Python library. And believe me, to build this UI, you really need like only, I would say, less than 20 lines of code to generate this page. It's not a big deal. And again, here we are also using this score and stuff. So this is another that I was creating with more control how you want to generate the data. So this can be useful when you want to mimic like what current CPU thing, and you want to backtrack, like if I'm able to like what should be this, what should I set this threshold should be. So this is just like plain find out, just generating the data and stuff. This is interesting. Log analytics. This is the most time consuming stuff. Whenever problem happen, you log into server, get the log files out and find out the problem, right? So this can also be automated with AI. So, or even simple Python script. So looking at the log this way, it's like cumbersome. But if you look at the logs in the table format, timestamp, whatever the label, message of original log, or in log, sometimes people put like service name in the square brackets and stuff. So you can also do extract and everything. Very simple analytics, no AI here, pure Python. Like how many debug you have? One. How many error info warning you have? Two. So just at a glance, you have all like put in like different bucket, all the error log, all the warning logs, and then you have a better visualization. So this is Python code. Okay, as we are on here, let's move on to, let's see the advanced version of it. So I will run it one more time, and here, this is based on LLM. So again, same kind of a log, but you just copy paste or upload the whole file here, and then it will do the summary using LLM. And I don't know what is this all about. So it is just saying application started successfully. Then we had a warning that CPU is going crazy, 75, 78, 88%. And then there was an error, data processor exceeding 95% for 30 seconds, performance degraded. And then data processor to like some initiating service restart, and this something we have in a log, and you don't need to even read it, just give it to your LLM, and LLM will give you all the summary that I talk about. So warning happened, then there was an alert, and this timeline happened. And then you can also ask the question, give me the steps to remediate this. So let's dive it, and it will give you all these things. So this whole model I'm running on my local. So this data is not going anywhere. Data privacy is also one more concern, right? So, or also the cost. This cost me nothing. If you use Chat GPT or GPT-5, 4, or Mini, OSS, whatever, like Gemini, DeepSeek, it will cost you something like few cents per million token. But if you have a power, you can also run it locally. So I have few things. DeepSeek 1.5 billion to Gamma is from Google. Coin is from one of the Chinese model, but it's good. So I'm running it locally on my machine. If I turn off the internet, this will also work. And I can ask all this question here. Why sky is blue? And give me the answer. It takes a time because I don't have NVIDIA graphic card on my laptop. So it's a little bit slow, but the good part is it's completely free to run. But yeah, it's still not like that much slow. So it gives his answer. This is completely running on my machine. And this is one way of using it. Another way is using the code. You can use Python to talk to it. It is running on your local host. Olama is running on my local host. And you can connect it using Python. So let's try to put one more file and see. Let's take something. Let's a network. I don't understand network. Okay, the file is uploaded and it should start the summarizations. It would take a little bit. If you have a GPU, it would be faster. This library is not supporting AMD GPU. So next time when you buy or build your computer, go for NVIDIA only because it's kind of a monopoly right now. So it is completely running on my CPU. So it will take a little bit of time. But it's back. I don't know what this log file is about, but you get a summary from LLM. So it says this log file indicates that system tried to connect to external API on this. So how good it is, right? So and it includes three distinct type of error message. One morning message happen like this. And then I say, okay, give me the steps to remedy this problem. Or you can ask anything what this DNS means. What is the full form of DNS? Okay, this happened at analytics.example.com. So was there any another error? Or what does this mean? So you can basically ask any questions here. Okay, so it's now working on this question, which was already there. So it will try to give you the steps to remediate the problem of this connection refuse stuff. So how cool is this? And this is really easy to, I would say, develop. And if you develop something like this right now, you are going to get a really good exposure, I would say. And see, the response it is good, I would say. It's not really bad, but if you use like really good model, let's say Quen model, but of higher billion parameters. So this is 1.5 billion parameters. So it's a really small model. But if you use Quen 400 billion parameter ones, it will give you like good answers. So we will see how you can use it for free from Open Router and all. So you can build LLM apps and stuff. And even though you don't work on, let's say, IT operations, this knowledge that you get of how LLM apps are built for this monitoring system, you should be able to apply that logic in other aspect as well. For example, let's say you have a DB and you have so many queries that, okay, why this happened, and you go to DB and then you run the query and get the answer. Now with LLM, you can connect your DB to LLM and ask all this natural language question. You don't even need to know the SQL. This is like application is limitless with LLM. Yeah, that's why I'm saying like on week 3 to 5 we would be mostly focusing on all this machine learning and AI and LLM stuff. Okay. And we would be applying it how in your IT, or I would say traditional monitoring stuff. Okay. What this AI application is, this is isolation forest one, scikit-learn. So let's learn it. The last one. So this is different from your statistical model. This is applying isolation forest, which is one of the machine learning algorithm. It sounds very fancy, but in theory, what it's doing is it's trying to find out the point which doesn't have the neighbors. That's what isolation forest is. Like in forest, if something is not inside the forest, that is an anomaly. So, and this is completely like, I would say you can run it on any data. It can be your even financial data where you are having, let's say, some chart and you want to find out the anomaly. If you have a tabular data, you can also run it. So it looks at all the things